Hey everyone, for this video we are going to be talking about trig ratios of any angle within a circle. So general rules that we're going to take is we are going to say that the circle has a radius r. It's not important that we know what r is yet. This is just to kind of break it down a little bit. So what I've already done for you is I have given the circle and I have plotted a point on the circle. That point is xy. From the origin being the middle, 0, 0, we draw to that point xy. The angle that is formed here, this angle here, is going to be our theta. Remember, this is our initial side, the x-axis, the side that moves, so the side that connects to xy is considered the terminal side. Key idea, think, how could we create a right triangle? What I'm going to do here is I am going to take from this point and I'm going to draw a perpendicular line straight down. And if you focus on this, I have now created a right triangle. Well, if I want to add some stuff to this picture, this point is at xy, which means to get to that point, I move x right and y up. And then the hypotenuse in this case connects from the center to a point on the circle. That's an example of a radius, so I call that r. Now here's my theta. I'm going to label my side. So across from my 90-degree angle is my hypotenuse. Y is across from theta, so this side is my opposite. And then next to my theta, x is the adjacent. And I can fill in my trig functions using these r, y, and x. So the sine is the opposite over the hypotenuse. We know this because of our word SOHCAHTOA. So in this case, the sine of theta is going to be y over r. You can go through, do sine, cosine, and tangent. I like to do the original trig function with their reciprocal. Cosecant is the reciprocal of sine. So instead of y over r, it's going to be r over y. Cosine, that's the c part of SOHCAHTOA, is the adjacent over the hypotenuse. So that's x over r. The reciprocal of cosine is secant. So that becomes r over x. Tangent, that's the TOA, opposite over adjacent. Tangent is y over x. Or the reciprocal of tangent, cotangent, is x over y. So you can always label your triangle with the opposite, the adjacent, and the hypotenuse, or you can also know that these ratios work when you are in a circle. The last thing that I do want to discuss, and I'm going to zoom out here so you can understand it a little bit better, the tangent of theta is the sine of theta over the cosine of theta. And the cotangent of theta is the reciprocal, so it's the cosine of theta divided by the sine of theta. So the reason why this works is because my sine ratio is y over r. And my cosine ratio, we scroll up here, is x over r. You have a fraction divided by a fraction. This means you multiply by the reciprocal, or you keep the first, change to multiplication, flip the second fraction. And what you should notice here, when you multiply this, you have yr over rx. The r's cancel, that gives you just y over x, which is your ratio for tangent. So another way that you can represent tangent is by the sine over the cosine. I can do the same thing for cotangent. It's x over r divided by y over r. Keep, change, flip. Once again, the r's are going to cancel. You're left with x over y, which is the ratio for cotangent. Okay, so we're going to do just a couple examples of this. So use the given point on the terminal side of an angle theta in standard position to evaluate the 6 trig functions of theta. What you have here is negative 4, 3. This is an ordered pair. So I move negative 4 in the x direction and up 3. I then take where my triangle ends and I connect it back to the origin and I draw in theta. We label our sides. I have the hypotenuse. 3 is the opposite. Negative 4 is the adjacent. Now, we're missing a side here. We plug it into Pythagorean theorem. So I have 3 squared plus negative 4 squared equals x squared. If you have learned Pythagorean triples in a previous class, you'll see very clearly that this is a 3, 4, 5 triple. But this is 9 plus 16 equals x squared. X squared equals 25. Square root of 25 is 5. So the other way that we can label these, besides the opposite, the adjacent, and the hypotenuse, is we also have the x, the y, and the r. X, y, and the radius. So my sine of theta is opposite over hypotenuse. It's also y over r, or 3 over 5. The reciprocal of sine is cosecant. I flip it to 5 over 3. Cosine is the adjacent over the hypotenuse, or the x over the r. That's negative 4/5. Reciprocal of cosine is secant. I flip the fraction, negative 5/4. And then tangent, the opposite over the adjacent, or the y over the x, is negative 3/4. The reciprocal cotangent is negative 4/3. It's just another way of identifying your sides besides opposite, adjacent, and hypotenuse, which is going to come into play more when we learn something called the unit circle. Y, x, and r are going to be super important. All right, so one final example we're going to do. This time we are doing 12, negative 5. So I'm moving 12 to the right and down 5. Remember, you are always then connecting back to the origin. There's my theta. When you are doing these problems, you're going to be finding the hypotenuse every single time because you're already given an x and a y. So I'm plugging into Pythagorean theorem again. This is 12 squared plus negative 5 squared equals x squared. Once again, if you know your triples, this is a 5, 12, 13 triple. Your radius should never be a negative measurement because you can't have a negative radius. That wouldn't make sense because it's a distance away from a circle. 12 squared is 144 plus negative 5 squared is 25. So x squared equals 169. The square root is 13, which we've already talked about. So I labeled opposite, adjacent, and hypotenuse. I can also label the x, the y, and the r. I'm going to keep going back and forth between these because it is important that you know each of them. So sine, the opposite over the hypotenuse, or the y over the r, is negative 5 over 13. Reciprocal of sine is cosecant. I flip that fraction. Negative 13 over 5. Cosine, the adjacent over the hypotenuse, or the x over the r, is 12 over 13. Secant is the reciprocal. I flip that to become 13 over 12. And the tangent, the opposite over the adjacent, or the y over the x, is negative 5 over 12. The reciprocal of tangent is cotangent. I flip it to get negative 12 over 5.